I think everyone's back. Cool. Okay, I think we're pretty much ready. I'm going to be going over the kind of where we've gotten in traffic ops with the CRUD framework. It's going to be kind of a dive into the actual code that we were discussing. So we're going to just start at the basics of how the traffic ops GoLang handles a request. So a request comes in, hits a basic routing handler that we have one of, that then goes through the routes, finds a match, throws it through its middleware, and then hits the handler inside. This is just a basic diagram of that. So we're going to go look at how the routing works.
Can I just say that diagram would be great in the documentation?
Yeah.
It will, like I said, got created this morning. It'll go in.
So routing handler is just routes.go file?
It actually lives in routing, but it processes the files in the routes. Routes.go, which is where we're gonna go look now. So the routes basically get compiled and built up. They're processed in the order that they appear in the routes file. We're using regexes for the matching, which is something that we need to think about in the future as we get to all of the however many routes we decided there were in Go. We may run into performance issues with the one at the very bottom of the file taking a long time to get routed to potentially. And that's just something to be thought about in the future when we're moving through. So the routes file looks like this. So we've got a whole set of routes divided by the version, the method, the HTTP method you're using, the path that it matches to, and
Plus a couple times.
Apple
Plus a couple
Oh,
times.
cool. Oh yeah, I meant to switch it to %. Anyway. There we go.
Oh, yeah.
Cool, there we go. There we go. Yeah, I meant to do that before I got to it. So we've got the version, the method, a path, the handler that we're using. And here we can see we've got some generic handlers up at the top there, whether they're authenticated or not, and what levels they require. Middleware. So here's a good one. CDN's capacity got mentioned, right? And that's one that we had to by hand pass it through to the Perl so that route will match to the Perl. So that's why we've got this proxy handler here. That's one of so there's basically three basic kinds of handlers. Which we're
getting caught up by that CDN's ID one, right?
Yeah, so CDN's ID down here was regex matching to all of these routes. Yeah. So we had to put them above it in the file to by hand pass it through to the Perl.
So if you were, because it does the first match.
Yeah.
Right, and it's not type checking either, right? So
yeah, because that would be the other thing that we could implement.
Where ID is a _D.
Yeah, exactly. Yeah.
Go away from we were talking about.
Yep, exactly. So we decided to go with this for now as the easier fix before adding more complex patterns into our regex
and
matching.
It actually makes it good for a bookmark as to what needs to be rewritten.
Yep.
So we can scan the routes file for proxy handler, that's a candidate for a rewrite.
Yep.
Yeah.
And then we've got basic handlers too. So monitoring handler, as you can see there, it doesn't use one of the generic read, creates, or updates. It's just the monitoring handler, as is ping, for some reasons that we'll go look at. So wrong way. There we go. So yeah, so those are what the routes look like. The middleware set that we were looking at over there, they're optional modifiers to our request handling, basically. So they're what we use to attach all the cores headers, the whole content SHA, which if you think about those two things, they can change the data on the way out as well as the way in. So you could modify the request on the way in potentially if you need to, or modify the response on the way out. You just have to have the middleware written properly for that.
Why do we need cores headers?
For the portal.
For the portal. The portal browser stuff requires cores headers. Yep.
The whole content SHA is it's just a sum, and if you have the same one, that's fine.
And that has to wait until the body's been written. Otherwise, we can't do that. So some of them modify on the way in. Some.
Does the client implementation do the whole content SHA checking, or
does which?
The client, does that do the whole content SHA checking, or is that?
Right now, the only thing doing that is ORT, and ORT does check that.
Does check it. Okay, cool.
So I totally haven't been paying attention to anyway.
Oh, no problem. So again, the middleware set over here looks like for ones that we want to use the default set of middleware, which for us is headers. That's all. It only applies headers by default. Yeah, we put in nil there. For For things being proxied,
For,
Yeah.
for us, non-Go users, what is middlewares?
oh yeah, middlewares is an array of middleware to be applied. So that if we have a special, if we have a route that we want to apply a certain set of middleware to, we can just apply whatever middleware we'd like there. So that's
Examples are what? Like,
so where I was getting to, the proxy handler, we don't want to add the headers to it, and we don't want to do authorization. So the middlewares is an empty set instead of a nil. So if it's nil, it'll apply the default middleware. If it's an empty set, it will apply no middleware. And then we also apply the authorization wrapper based on the authenticated flag.
Somebody's going to be writing some documentation, right?
There will be, is
Because
somewhere.
that's not necessarily, you walk up to this and you're like,
This will definitely, a lot of what I've done here will be trying to get into that document showing how to rewrite stuff into Go.
This has evolved a lot.
Yeah, it's been,
yeah.
yep, exactly.
And it was from an outsider. If you're not in there with you guys in the pool every day, there's no way you can keep
Yep.
track of this, right? So I just let completely go, and I was like, I'll catch up on this when you guys present it.
Yep, that makes sense.
No way, there's too much going on.
Yeah, I think we had one guy try to add some new routes to the cache groups and get pretty turned around.
Yeah, I could see that happening.
Yeah.
Dude, the middleware is really have you guys thought about calling that plugin? Probably had a long discussion about that. But it feels like a plugin more than a middleware to me.
Yeah, it could be a plugin. That's a good point. I went with middleware because that's a pretty standard name that gets used in Go when you're applying it to routing. But that was just
Yep.
I just made that call and called it middleware.
But the association with calling it a plugin seems reasonable.
Yeah, I agree. Could be an authorization plugin. But yeah, so we do user authorization there. We'll in the future we'll probably handle the capabilities check with a wrapper too, because basically how they get structured is as you here I gotta exit. I can't believe you can't change files here. And they don't even give you a shortcut button for it. So yeah, the compile routes is what goes through and processes the regex pattern, make sure that's valid. And then in here, when we do create route map, is how we apply the middleware that I was discussing and the authenticated. And so basically, it creates an array of these handler chains that get applied. So you'll come in, and the first thing that you'll hit is the headers middleware, and that the headers will get added, and then you'll hit authorization, and if you're not logged in, you'll get kicked out. And then if you are logged in, then you'll get handed down to your handler. And at that point, the authorization wrapper will have added in all of your required user information into the context. So that's one thing. We are using context here to pass in this information down to your handlers.
Is this that onion model that they talk about in Go?
Yeah, exactly. So once you get to a handler, there are the three types that we talked about, which is the proxy, which is just handing it directly through to the Modulicious server, and we don't do the headers or auth there because we know that Perl handles that itself, and we don't need to do twice as much work. And then we have the standard handlers. When we first started writing the handlers, they were all standard handlers that came in. You unmarshal the JSON body into a struct. You collect the path parameters and URL parameters off of the context, which is where the router puts that information for you. You'll do a tenancy check potentially. Then you actually handle the request. Then you need to write a change log and then build a response body and set a response, like the content type of your response, and then you can return your body. That was our standard one. For ping, for example, you don't need to do that.
What does ping do?
So ping, I have open over here. Ping just is a very basic handler that looks like this, which can I just, Command plus doesn't do it. It's a health check to show whether or not the server is up. So it looks like that, which is very, like far much simpler than all of the steps needed for handling a JSON body coming in. So that's why we don't want everything to be forced into the CRUD framework, because there are endpoints like ping or other things that don't fit that pattern. So we don't want to like handcuff ourselves into doing a CRUD framework, basically. And then the generic CRUD handler came from the idea that we have all of these steps that have to be done every time for most of our requests, for like 80%. So we wanted to standardize that. So we normalized all the steps up that we just went through above in around a create, a read, an update, or a delete operation on a struct. So what that looks like is, so the handlers are over here. You define it onto a struct. So the CDN struct gets defined and gets all of these interface methods defined onto it, and then that makes it so you can CRUD a CDN. The interfaces are what we'll look at first. So we've got an updater interface, which has the update method. And it requires you have the identifier and validator. So identifier is really important because it's how you define what is the important information about your struct and how do you tell what struct it is in the DB, what's the important, what are the keys basically to use. Creator, you have to be able to set keys, right? So on a create, when you write to the database, you don't necessarily, for where we're using ID as our primary key, you don't know the ID when you do a post. You don't set your ID. The database gives it to you. So we needed a way to be able to set the ID back onto the struct before we hand it back to you in your response. So that's why that is there. But again, why can't I jump to an actual implementation here?
You can probably use show definition like that.
Yeah, it's because they're interfaces, they won't actually jump to one.
Oh, yeah.
Yeah.
You're there.
Yeah. Yep, exactly. So here, we'll look at where it gets used first. So, yeah, perfect. So we'll start with the read. The read handler is a pretty simple one because it takes in what your request is, what your path. You're not going to have a body there, so there's no decoding of JSON or anything like that. So we come in, we set up a handle errors function, which is just a helper function that will set a response code and properly build an alerts struct that we use to tell you what went wrong. Then we grab the context off of the request, which is again a structured object that gets passed down with everything. It kind of breaks the cleanliness of the code because it's not super clear that read handler requires a user info there, which is kind of a bummer about using context, but it's a trade-off that we had to make. Then you grab your parameters off of there, and again, this is happening for every single one that is doing a read. Get our user, and then we call read on the type ref. So this type ref comes from the routes file, where we call api.getReadHandler. We hand it a cdn.getTypeRef, which is a pointer to the struct, because we have to preserve the type information there. Because Go doesn't handle generics well, so you have to, yes?
Do you have a missing return statement on line 137?
Yes, I do. That is an issue there, for sure.
Sorry.
Yeah, that one should have one. That's why all the other ones return after calling handle errors. That is definitely
These things is not like the others.
Luckily, that failure shouldn't happen too often, apparently. But yeah, that's a good point.
That was an intentional test for us, right?
Yeah. I was hoping I pulled that out. I'm not just on master. Actually, I am. But so then the read interface is defined, right? It takes in a database, it takes in your parameters, and it takes in your user. And then that allows CDNs to do whatever it needs to do to pull the data that you're looking for out of the database. Because we don't want to make too many assumptions. We could make the assumption that a read always will just be issuing the same select statement, but that gets us that starts to hit the issues of flexibility versus like how verbose we want it to be. So we don't necessarily want all of our implementations to just be issuing some SQL. Because, for example, the delivery services need to do a lot more logic than you'd want to try and represent in just SQL.
What's this file called? This is specific to CDNs, or is this?
No, this is the shared. This is the generic. This is the generic code. Right here, the type ref is called type ref. That could be a CDN. That could be a delivery service. That could be a server.
If you're doing a standard read from a table, you don't have to do anything. You use this, and you don't have to like cut and paste.
You still have to. You still have to cut and paste some, and which is what we're going to go look at now. So we're going to go to look at the implementation of CDN read now.
Yep.
So again, this is that get ref type method that gets called in the routes file, and it just gives a pointer to a single struct, which is something that we'll address later. As actually we have a concurrency bug in one of our generic handlers because of this, because I hadn't fully thought through delete when I did this style. But there's changes coming that should address that. So you go through, once you have all of the methods required defined, you can hand it in to the get read handler, and then you'll have an HTTP handler that will do CDN reads.
So, sorry, Dylan, go back up a little bit.
Yep.
These fields are basically defining and communicating back to that generic read information so that it can use generically.
Where's the get read?
We're getting down to it. There's a few. Most of a lot of the ones that we're looking at up here are used for the update and create and delete ones. And the audit name, for example, is used for logging. Because again, that's one of the things that the generic create handler does for you, is it will do a change log for you. So you don't have to do your change log in your implementation here. So once we get down past validate to read. So CDN read, right? It matches that interface that we looked at before. It takes a database, the parameters, and a user, and it returns an array of empty interfaces. This is because it can't, because it's a shared interface, our interface can't return a type. And since there's no generics, we don't have a way to say it's returning a generic item of ours. It has to be an array of empty interfaces, which is again one of the weaknesses of Go not having generics, is we have to do stuff like that in a few places.
That's
But
not uncommon. You see that in SQL and JSON in the standard library.
yeah, the standard libraries do it quite a bit. It's a very pretty standard thing to do for stuff like this. So when you come in here, some of the important things that you need are a way to map query parameters off of the URL to the database where statement that you want to build up. So that's what this chunk of code is doing here. It's showing that if you hand in a domain name query parameter, that's mapping to the where column of domain underscore name. And so every time you create a new read implementation, you have to create this for your for the struct that you're using if you want it to be able to use where columns. API.isInt here is so that we can validate that it is the proper type instead of throwing a 500 when we try and use a non-integer in our call to Postgres.
And it does all the right. It makes sure that it takes it and does the A2I and all that other stuff for you. Because
Yep, exactly. Because it will automatically be doing that before, but this API is int just verifies that.
And this is actually where we run into a lot of sticking points.
Yeah.
With the old Perl way of doing it, with the double quotes and figures.
Yeah.
I'm surprised there wasn't a lot more standard Go stuff for that. To say query param, it's in query param.
There's some stuff that they just don't build for you because they want you to do it. But yeah, back to
Pain.
yep, exactly. So back into CDNs again. I really wish they gave a key for that.
Not order by, build where, and order by all of that, and are you using bind variables, I assume?
Yeah, exactly. So yeah, so then it doesn't. There's no way to do injection really because of how we build up the queries using binds. So it only will insert the value of the type that it's expecting in a quoted style. So you can't even put in, like, if you put in a crazy string that has SQL in it as a string, it's going to quote that, and it knows not to try and issue it as an actual query. It'll just fail as a non-match because it quotes everything.
Context of this. Now, obviously, somebody could write their own SQL.
Yeah, for sure, but the wrappers give the protection.
Yep, exactly.
And consistency, which is really what we're after.
So once you've built up your where order by, so order by gets handled there too, because you can pass in an order by query parameter there, and you don't need to define that for every struct. We all, for almost all of them, I believe they all will apply an order by if it's there. And actually, Dan recently has a PR for making it so you can have multiple order by parameters, comma separated, which is cool. But yeah, then we build up our query using the base select, which if we look, will be down here, so we'll jump to that. So our select query here is pretty basic, right? We're just grabbing out the columns that we need, and that's all. And then we add the wheres to that if we're selecting by ID or something like that. The update we can see here always is using ID as our where, because that's our primary key. Put back up. So yeah, once you have your query built, we log it just because it's nice to be able to see what query you're using. The really nice thing about using clean SQL rather than an ORM necessarily is that when you get that query log, you can copy and paste it into Postgres and run it and verify your output, which is a really nice thing about using clean SQL. Then we issue.
The query question marks and all that is already filled in. You can literally cut and paste it.
Yeah, we spit that in the log file, so you can.
Yep, exactly. And then you have to do some changes because it does use some. You have to like put in your parameters. It won't
Okay.
print the actual SQL, but yeah. Because then it issues the query using your values that you got from up here. And if there's no errors and you're good to go, we run through each row that's of the response and stick it into this. A struct scan is a helper function that SQLX provides that goes through each of those columns and sticks it into the proper value in the struct based on the struct tags. So that's what that's using to do that there. As long as that all works, you return a list of CDNs. And again, here we didn't have, CDNs is defined as an array of empty interfaces, right? So even though within the loop, we're saying it's a TO-CDN so that we know how to deserialize it out of the database, once it's actually being returned, it's still that empty, it's an empty interface. But empty interfaces can be JSON serialized just fine. So that gets up there into the read handler, back to the read handler now.
How do you catch the mismatch between your struct definition and your actual service query columns? Those are handwritten.
Yeah, these are handwritten. So that's something that we've been talking about, and we want to start using constants probably for the query parameters. I believe we've been discussing switching those to so that each struct will kind of have a set of constants.
Is the TO-CDN struct also reversions?
So back to my discussion earlier, it's getting there and sort of yes.
So
because of the way we're going to try to do anonymous structs.
Yeah.
Remember that discussion earlier?
Yes, that's a nice concept.
Yes.
How do you tie that into the actual queries, SQL queries that you're going to write? Because you're going to have optional fields that you have to grab.
So the way that we're currently doing it is the older ones we'll call the newer ones because the newer one has to be backwards compatible. So we'll always call the newest one and then we'll turn it into the oldest.
Get the largest one.
Yeah, so
Yeah.
technically they're unnecessary things or unnecessary data, but I doubt it will impact performance.
And so yeah, this is another one of the things that's a little interesting that we're doing here. Because you can't define methods on a struct not in your package, we have to alias it. So we pull in GoTC Here. We pull in GoTC and GoPC v13. Use v13 as define our own type that is just a alias, right? So we're just now we have TOCDN, which is really just a CDN nullable from v13, but that makes it so that we can define all of our functions on it, which is an important thing there because we need to be able to have it define the interface. But yeah, so that's the basics of how that stuff works. But let's get back to the read again to look through it. Oh, it jumped back up. Great. So so the read that we just went and looked at the CDN read. When it returns, if it returned without errors, we know that we have an array of one or more, potentially zero, structs that we need to marshal into a.
And it knows the type there because you were
It-
doing an empty interface. How
It
does
doesn't.
know
It
the
doesn't
type?
need. It doesn't know the type, but it doesn't.
And it doesn't know what struct to serialize.
It has all the fields there.
So what's happening is it's being deserialized as JSON, and so the JSON built-in libraries take an empty interface and they do reflection under the hood.
Yeah.
So his code, our code, doesn't know anything about it, but the underlying JSON is going to do reflection.
Yeah.
Am I the only one who thinks that's very surprising?
It is a little bit surprising, yeah. But it's because of how how the Go JSON handles.
You didn't make it JSON in the other thing. You just said it's an empty interface and you put the struct in.
But you gave it a struct that has fields and those fields have JSON tags, and the Go built-in JSON libraries will do all of that. The SQLX does the same thing for the struct scan.
Well, remember the struct tags, you have to convert from a struct field to the actual tag that goes on the way out, so it has to have the ability.
Maybe
To go look at the struct
I'm
tag.
probably not smart enough to understand this,
Yeah,
but
it's-
I would feel like there was no way for it to know.
It does know though. At that point, it still has.
Runtime, but it's not C++. Go actually has a runtime, and it's got that data for struct tags and other things actually at runtime, not at compile time, and that's how the reflection package works. It's ugly and it's painful, but that's how it works.
So yeah, so because we have that type, so then we just build up a response struct, which this is a style thing that might be nice or not, but I do an anonymous struct to do it. So I'm just saying that
Yeah.
our response is an array of interfaces with the JSON label response, and I build it up with our results, which are
You
from
have
above.
to do the CDN response wrapper.
Yeah, instead of having a struct
But
that
is there
says
more to that thing than just that?
no.
I thought there was something at the bottom as well, right?
Oh, our reads don't do alerts usually.
Oh, okay.
Yeah. The other ones do. The other ones do
And
use
you have
alerts.
to
So
do
the
that
other one.
as well, because
Yep.
there's no helper or anything. You just do that manually.
Well, actually, there are the alert. I built up alerts helpers that get called to do it. But yeah, so then once we build that response, we do a JSON marshal
Yep.
and set our content type and write it out over the wire. When that writes out over the wire, the header wrapper basically uses a body interceptor on the way in, so it's not actually directly writing the body at that point. It's writing it to a body interceptor, which then the header handler takes that body, runs our whole content SHA-512 on it, and adds that as a header on the way out. So that was what we were discussing about how some of them make changes on the way in and some on the way out, and that's because we need to be able to take
What does
that.
format colon do? Is that optional or is that?
Oh yeah, this is my editor adding that in. You can actually,
What is that?
yeah, that's from the editor. Anything that's light gray like that,
That's what the field is on,
yeah,
the method he's calling.
yep, exactly.
How do you know what your editor adds? Is key and value or?
Because it's grayed out, yeah.
Yeah, it's grayed out, so it's not a real character.
That's all,
Yeah, that's because I'm using GoLang, yeah. Yeah, so let's look at an update, because there we'll see it actually do more of the stuff. But yeah.
Have you thought about returning something other than JSON? having the option to return something other than JSON?
Yeah, that would be a really good change to have in there, to not only be JSON reliant, but currently it is all assuming JSON when you're using the generic handlers.
But it wouldn't be that hard to change.
It
right?
wouldn't
Because all
be.
this machination stays the same until there's serialization at the
Yeah,
end.
yeah, exactly.
Working with Ansible, it'd be useful to be able to return it in YAML format as opposed to JSON.
Yeah, that would be pretty. That would be a cool thing to be able to do, and it would be something that maybe you'd have. It could be an extra parameter that you hand into your
Or a
get
dot-
read handler.
.yaml or a .json, right?
Exactly.
Yeah, or-
Exactly
or
right.
use
That's
the-
exactly what I was thinking.
You could use the accepts. Yeah.
Here's the sticking point, that means another dependency to flip to YAML. That's not native to Go.
But
Yeah.
yeah, but yeah, you're right. It could also just use the accepts header off of the request to make that decision, which would be pretty easy to do.
Yeah.
Yeah, so an update is more interesting because we have to decode and validate our request body before we start this. So once we decode and validate, which I'll go show what that does, which flips it into a updater type. And here, the special thing that we do in there, because of that type reference thing that I was doing, which is a shared struct, it actually creates a copy of that struct, so we're not using a shared piece in memory, because that would cause all sorts of concurrency bugs. So once we pass right here, we have a local object instead of the shared one across the entire across all of them.
So the decode and validate request body copies it?
Yes, which is that's being fixed. That was because that was an issue that I ran into and fixed and came up with that way to fix the problem. I now have a PR that I'm working on that addresses it in a far better way by creating a singleton that produces a new struct every time you call it in the handler. So that's one of the things that I point out as a future change, because it's needed, because the big thing is our delete doesn't actually call decode and validate because we don't need to, which means that it's delete is every single time you call delete with one resource, with one struct, it's using a shared struct. So if you concurrently call delete a bunch of times on the same kind of resource, we have panics.
So I found that in our API test tool.
Yep.
But we don't really delete a lot through the API, so it's not that
But yeah, but again, we do have a fix on the way, and it also just makes the code a lot cleaner than the hack that I did for this.
So I did another fix that solves the same problem in the delivery services PR. Because I had the same problem. I had to add the config and the database to that type graph.
Yeah.
And the way I did it was in this handler, when it gets it in the credit stuff, it uses a reflection to copy the object.
Okay.
It was a really nasty line.
Yeah, that's what decode and validate is doing. Actually, decode and validate copies the uses reflection to copy the type, which is why when you call it, you're safe. But if you don't call it, you aren't. But again, I have a refactor that again is doing the same thing. It's coupling the database into it, because we really don't want every interface to be tied to the database, because we might be deleting something out of React potentially in the future. So we don't want the interfaces tied to the implementation. But that'll be something I'll get into in a bit. But yeah, the big thing here that I wanted to point out in the update is once we go through and we know what keys we're doing. So this is another big change that came in. When these was first written, we assumed that everything was ID based. So then immediately when we got to profile parameters that don't have an ID, you couldn't use the generic CRUD, which was a problem.
The key that was outside of the ID.
Yeah,
As a key.
anything that wasn't ID as a key. So now we have the idea of keys as a definable piece of information about a struct. So you tell it what keys you want to use. Most of them currently use ID as the key.
That supports compound keys.
What? And it supports compound keys. So you can say that your key is profile and parameter for the profile parameters, for example. And then we have a check if it's a tenable object. which means that you've defined the interface on it that checks tenancy. We check the tenancy, and we'll toss you out if it's not in your proper tenant.
So you come here.
Yep.
Was the tenant check in the read handler?
So for reads, because we may want to, if you call get all, we want to check it for each one of them. So for that, you actually have to handle it
Filter out.
or filter them out based on tenant. We do that in the actual implementation of read rather than in the on the generic side, because it creates more. It's almost more work to do it afterwards in the generic side. And then again, we do the create change log. So this is that's the part that makes it so that we don't have to do that in every implementation. You just tell it that it's an API change, we've updated it, and this is the object that we updated. And create change log comes in and builds up a message and a query to insert it, and inserts into the change log. And all of these are being done post the transaction. So
Do you have an example message?
an example message.
So remember,
Maybe.
this is the default one. You can always override in the handler. But
Yeah.
Where we're going to get to the point where, each handler is going to groom the message to make it more reasonable and understandable. So
Yeah.
we'll get more value out of the change log.
Yeah, so we have a base one that just tells you the action that you did to the type, and then whatever your audit name was, and then what our keys were, and that's the very basic one. If you implement change logger, we instead overwrite that message with whatever message your struct returns as its message. And again, at that time, you have all of your fields filled in, so you know what information you're trying to log. Let's go back to
Not all users can see it.
Correct.
So this is going through what I just went through. I just didn't use my slide, so so we'll skip that. I guess we should go talk about validator, though. Actually, that's a good thing. So validator is the idea of taking a look at your struct that's coming in and verifying that it's actually a valid database object. Because we have lots of rules, right, that Perl checks on the way in to make sure that you aren't creating a server with a string as an IP address or something like that, So validation for CDNs is pretty simple, obviously. But we use a framework to make it a little simpler to return your validation messages. So, for example, for CDN, we validate that our name is there and is so required. It applies all of the checks that are there. So it's going to say that it's required. So if it's not there, we're going to fail validation. If it's not a valid name, we're going to fail it. And same with domain name. If it's required, and if it's a valid domain name, we're good to go. And so again, valid CDN name is defined right up above here, and all it does is make sure that it's a valid CDN character. And domain name is doing domain name, I believe, actually is a DNS name. So this is, again, out of the package. So we didn't write the method to check a DNS name. We used one out of the package.
So this framework will do setter validation, IP addresses, all the things we care about, ensuring that the format is correct before we even apply it to the database.
Yeah, and the nice thing about how we're checking them here is instead of if you send up a CDN without a name and without a domain name, it's not going to tell you that you don't have a name, and then you add the name, and then it's going to tell you don't have a domain name. All of the checks get applied at once, so you'll get back a set of alerts telling you everything that's wrong with your struct, field by field, rather than getting them piece one by one, which is really nice.
That said, I think we should And I think we should have both. You get better
Yeah.
messages. It's good to check it in two places.
Yeah.
But we can make things like Postgres types. There's a custom Postgres type that's a CDN.
So an example of that, of where I decided to move validation to the database side, is I actually, for one of them, I added a uniqueness constraint that was being checked in Perl, but not actually enforced in the DB. Enforced it in the database, and then when we do an insert or a create, we actually parse the errors that we get back from Postgres. And if it's a uniqueness constraint error, we know how to handle that and properly return an error message saying that you failed the uniqueness constraint on this field. And so that again is a way to try and rely on the fact that the database already can do the uniqueness check without doing multiple queries. Some of the things we still do multiple queries from validation. But
does it translate the uniqueness failure? I know that the Perl traffic ops would bubble up the uniqueness constraints verbatim, the failed errors. Does this kind of parse it? Yeah, exactly. It parses it into an alert that I believe it actually matches the field name in the JSON. That I'm not sure. It may actually use the database field name. That would be something I'd have to check.
I think it does translate to the JSON.
It does? Cool. That's awesome.
Okay.
That's good. Cool. And then again, at the start of everything that's actually updating something in the database, like a create or an update, we begin a transaction. So a lot of we ran into bugs before on endpoints that were failing out halfway through because they would time out in Perl, where it would mess up our database state by stopping halfway through applying a whole bunch of database transactions. So at the top of create, update, and delete, we start a transaction that we can roll back if we need to. So if you're doing, so for example, in delivery services that Rob is working on, has a PR for, there's multiple places where he talks to the database, does different things. All of those are using a single transaction so that if at any point there's a failure, all changes that have been made get rolled back and you're at the clean slate of not having hit that endpoint yet.
We have a success and deliver success. Sorry?
If I want to take an example for that. So if you have a new delivery service and you have multiple registers, and so it would be a single transaction.
Right, and it actually needs to happen with read as well, so that read gets a consistent view.
Yeah, that's a good point. Yeah, we should be doing transactions for read too for the consistency of the view. Yeah. For example, so hardware info should use a transaction probably because it hits multiple tables and combines the information.
So if you want to further break the delivery service table, to normalize it.
Still do transaction.
And again, so if you notice, I don't do anything. I don't ever reference the rollback when we have an error. I just return. And that's because we're defaulting rollback to true, and then we have a deferred function. So defer basically anything that you defer in a Go in a Go function gets called as you exit that function. So as you return, defer is called, and so this is basically a closure. So it's a function wrapped around the variables that we defined up above. So once we get anywhere that we hit return, we immediately call this code. And so if rollback transition is false, we're good and we exit and the transaction is applied. Otherwise, we call a rollback, and if there's an error rolling it back, we log that. But we can't return that to the user. We got into a whole mess of trying to... I wrote some very complex code to try and be able to return a rollback failure to the user, and that it ended up just not making sense to do it and was overly convoluted.
We can put that in a helper function that takes the Boolean pointer.
Yeah. And it was something I also don't think that a rollback failure is necessarily something that the user should see. It was whatever they should see whatever problem made us try and roll it back, not that the rollback failed. But yeah. And so then right at the end, once we commit and before we return, I I just moved something. We set roll back the transaction to false. So that way, when we hit that deferred function, we don't roll back the transaction. It actually stays committed. But yeah. What else? So a couple of these I already talked about. But so as we, in the future, move away from ID as a primary key, or just for profile parameters and some of the other things that aren't using ID, we had to change it to use the definable key set. I want to remove the database reference from those interfaces because it decouples the implementation, and we could then have create, read, update handlers for React, potentially, right? Instead of it being tied to it being in the SQLXDB. And then replacing that type reference with a singleton, which is very similar to what Rob did in his to make it work, but I can show. So yeah, if you notice, create on CDN now, it doesn't take in a database. And I changed the name of the type, which I'm not sticking with this necessarily. I'm still doing dev with this. It's called TOCDN with database. So if you notice, when we pull off the database, we call cdn.database.begin to get our transaction. And that's because up here we have our type CDN defined as database with a nil JSON value. So that means that we don't want to serialize our database information into the struct when we send it out. So I removed that there. And then it's just got the anonymous CDN nullable inside of it. And then again, I changed it to this get type singleton, which gets called out of the routes and returns a function that returns a CRUDder. So again, this has a whole bunch of changes in it that try and clean up what the interfaces look like and how they're the safety for concurrency.
So a question, so why not just in the get type thing, get type singleton or get ref type, why not just make that construct the TOCDN with DB when it's called? That's what I did. Is there an issue with that?
No, not necessarily. I just defined the type at the top to have it defined up there. It could definitely be defined inside.
I think we do want to have one way of doing this stuff, right? So I think we need to agree, like.
Right. So his PR is open and it's going to go in there. This I've been trying to keep it on top of master, but it's not quite ready. It will be something where I will figure out how to deal with the conflict with his and make it all.
Doing the same kind of thing, solving the same kind of problems as he's doing servers and I'm doing delivery services.
Yeah.
So we've been solving the same problem, and we'll reconcile it.
Yeah, we'll be talking.
The one thing we don't want to do is have, even in the code, a couple of, or one, maybe we only want to have one way of doing it.
Yeah, that's what the interfaces. The interfaces hold us to that basically. That's why we're using.
I still see there's more movement than I thought there would be, hearing from what you're saying, and B, I don't know that the documentation actually tells me what exactly I need to do if I wanted to go take table X and make it
right. Yeah, and so one of the things that as I was writing this presentation is thinking about is I'm going to use a lot of the information that is here to update the guide that we have.
I think we need to stop making it perfect and start making it done.
Yeah, for sure.
Yes.
But again, this is
Right, because I feel like there's always something better, but we just gotta have one way. That's all we gotta do, and then we gotta stick to that one.
Believe me, we have to do this for self-service, and we're going to get it done.
Yep.
It's not going to happen.
Yeah. So one of the things again, I really didn't like. We don't the amount how the interfaces were defined was making our lives a lot harder, and was making it more difficult to write it. So this is also one of the changes that I made was reorganizing the interfaces. It actually doesn't change the methods at all. It just groups them into a CRUDder and uses that as a single type, and it makes it so that we can avoid the nasty reflection to copy the type, basically, was what we wanted to avoid, and have a single interface that we're using. But yeah, any other questions and stuff, basically?
So the recent changes are lock it down, document it.
Yep.
Those are number 1 and 2,
Yep.
right?
Yeah, exactly. And we're working. The lock it down is what we're trying to do right now. And again, anytime that I do a change like this, it kind of changes everything. I go in and just change everything to do it, which is why it takes a while to get them all up to speed. That's why if you go look at my
Because the more that you have, the more ways,
Yep,
the more
exactly.
drag you get when you want to change.
Yep.
And that's why sometimes even though you know that you have a better way, you may not want to do it because
Yeah.
of
the
that.
concurrent the bug that we have with delete, it causes panics, and it's worthwhile. We do need to fix that, and there is another way to fix. He fixed it by doing it in the handler specifically, but it's definitely something.
So that's why the testing and the test frameworks and anything that we can do more to test is more important.
Because again, the nice thing about most of the changes that I was describing there, they don't affect the API whatsoever, and most of these actually don't change the implementations of the interface either. They're just rearranging it a little bit.
Do you envision, like, as Dwayne gets farther along with Swagger, like maybe you just go in and say, I want to create, I want to CRUD foods, and it builds a scaffolding, and it spits out, generates all
Yes.
this
I mentioned
code.
that in my talk.
Yeah.
It's all stubbed out, and you don't,
Yeah.
you just have
Yeah.
these methods that are created, and you
Yeah.
go in and put your logic.
Yeah, code generation is something that I've been spending a decent amount of time trying to figure out how we can do that in a good way. Because one of the things is there's a lot of boilerplate there. For all the ones that update is a very basic update SQL statement, you're copying and pasting code and changing the variable name. But we have to do that for the strict typing that it has, and because we don't want to handcuff ourselves. For example, the delivery services update, we don't want to represent all of the logic that happens there only in an SQL statement, right? If our interface was update returns an SQL string that you use and all of the other stuff is the same, we couldn't have the one-off stuff like delivery service needing to go do DNS set keys on an update potentially and stuff like that. So that's why it's always a trade-off between consistency and like verbosity. So, but being able to have the flexibility that we get by actually defining the update interface is really important.
And along the same lines of documentation generation, I've also suggested it would be really nice if we could figure a way to automate the testing. So if we could do either code gen or reflection or something similar to this for the API test, so that you could just say, do or generate or run API test for my CRUD interface. That would be really handy.
Yeah, exactly. And these are all things that we want to move towards, and yeah, code.
So one of the things I see is when reviewing a PR on this, it's like you said, it's got a lot of boilerplate.
Mm-hmm.
So my eyes are like boilerplate. And I don't really see, it'd be nice to somehow abstract that boilerplate up.
Right, and
I
that's
can see just the business logic that's getting applied.
right, and that the issue there, right, is the delivery services example.
And you realize that's what the CRUD is, right? So the CRUD is abstracting a whole lot of stuff.
Yeah, but it's all wrapped kind of around.
Right, we
You
just
have to
figure
kind of
out
go through and
how-
say, oh, that's the piece I need to review.
But isn't it in you have the validator? The validator is I see it as optional.
Validating your struct.
Yeah, it's
Potent- You can if you have it return true.
let's see.
Validate isn't boilerplate.
What it shouldn't be.
Well, right. Validate isn't. That one, the content of that one changes a lot. For the reads and updates for many of them are very similar. It's just copy and pasted. You change the where column stuff. You change a few of the things. But the reason for that is because for delivery services in particular, that is not what update. Update doesn't just issue SQL. It has to do a lot of other
It's
things.
created in some other method that do an enhancing of the data. Okay, maybe a separate, an additional function that the entire non-boilerplate the logic goes into. You need the enhancement anyway. For example, when I worked on tenancy, okay, I added it as an optional field. Okay, so if the put method didn't have tenant, I would read it from the database and use whatever in the database because I wanted to keep the I didn't want to break the API. So you'll need some kind of enhancement method anyway in the update. When you get the data, you enhance it. You some kind of manipulate it.
So
So
this is
CRUD implies just the generic stuff, right?
yeah.
Creating, updating, deleting,
Yep.
database stuff. But that extra wrapping, what's that extra stuff you want to do?
The
Maybe you want to call React. Maybe you
Yeah,
want
let's
to check
see what
tenancy.
you-
Maybe you want to add 1+1. You know, it's like just making that clear and pulling that out of the boilerplate somehow. 'Cause I'm just afraid the PRs they get overloaded with the boilerplate.
Yeah. If we can find ways to abstract that out, that it is
I
a
don't-
really good idea.
I mean,
So
what you're asking is, that's what the CRUDder does, and the stuff that's left is stuff that that isn't a good way to do, or we haven't seen a good way to abstract. Just a lot of it is because Go doesn't have good metaprogramming, but a lot of it is because there are differences in the tables. So it's not just like delivery services and servers. Like, there are a lot of one-offs. It's probably a quarter of our tables. So a good one that comes to mind is delivery services regex. Right, so the DS regex table, when you serve that up, you don't just serve the table. It's like 3 columns. It's delivery service regex and
Because it's a joint test.
So,
Yeah.
yeah, but you're also serving the name of the type. So it doesn't serve the ID. That endpoint just happens to serve
It's
the
a
type.
joint table with an extra field.
So it's just got a little bit of logic to translate the name into the ID that
Yeah.
you've got to have special.
And I don't know that we want to optimize this anymore. I think that we're already in the area of optimizing too far. I think we need to get going.
And
Plus one.
I think we can come up with some more healthy functions. So like not all the complex reflection stuff, but maybe just, hey, these things are all doing the same thing. Like you're saying,
Yeah.
it's like boilerplate. Maybe we can write just a normal function that
Yeah.
helps.
I think those are exactly the point that bring you velocity in the future. So
Yeah, they bring velocity in the future, but they've been dragging us down for 2 years now.
And see,
That's
We
true
just need
too.
to rewrite all these APIs, right?
Yeah,
And
so
then we're
I
gonna
think, I
find-
really think we need to lock it
Yeah,
down.
th-
So
We'll
this is
find
how
all
we're
the
doing
copy pasta places where we
Yeah.
can.
Yeah. And that's what we've been doing
We'll see
basically.
that stuff until we rewrite it.
Yeah, and that's where I'm at. Like again, we've got to have a free self-service. I am just gonna do it. I mean, maybe people reject my PRs, but I'm gonna make stuff work, and then, like you said, later we can go in and say, okay, here's some copied stuff we can abstract it.
Right.
But-
And that's kind of how this has gotten here. That is what has happened. That's why we went from the CRUDder assuming IDs to using keys, as we realized that it was not genericized properly. And then once we started seeing more and more boilerplate, once we were realizing that in the standard handler, specifically this chunk, once we realized that this set of steps was being repeated everywhere, it was pulled out and genericized to be able to abstract it.
And to be fair, we really tackled, I mean, we're up to cache groups and physical locations, all the lower level dependent data items that are needed for the delivery service. So really, we're really at that point to the last mile of delivery service.
Yeah, we have a lot of stuff written.
We've been there before. We've had implementations that were just as far along, maybe even further, and they got all nixed because we kept optimizing and talking. And I'm saying we need to stop talking, stop optimizing, and start coding.
I mean, if you look at this list, we've got look at how many are here. This is a lot of Go code.
Have you guys thought about using RAM facilities? Speaking, code is not object-oriented language, but you guys must have thought of it.
Yep.
Yes, there was a huge discussion about that.
Yep. And we've had multiple, we literally have multiple implementations in Go based on reflection, based on code generations, based on ORMs. We've all gotten them to a certain point, some of them actually further than what we are now. And then we started talking and optimizing and never got anywhere. So that's why I'm sort of pushing for this. Let's just.
Well, this is in production.
Yep, like this is Go.
Yep,
Let's go.
it's in production and it's
I am
out there running.
applauding, and I said, let's go.
But like you said, you gotta have one way because you don't want to learn 5 of these.
Yep.
Yep.
Once the framework was in place, I was able to knock out quite a few within
Yeah.
several PRs.
Yeah.
So there is a testament to.
There's a little learning curve associated with it, but
Yeah.
once you get through it a couple times,
Yeah.
Let's go.
you get.
Even
going
Jeremy
fast.
wrote one, so that's.
Yeah.
Is this
I'm
in a
all,
branch?
I'm on board.
Yeah, this is my branch. Yeah, it's almost ready to open a PR. I just need to get all of the last APIs rewritten. And again, the rewrite is really just moving stuff to use that database field. And yeah, one of the things is as we do this, you're essentially getting closer and closer to building your own ORM anyway. But the nice thing that we have is one of the nice things about not using an ORM is that we get to look at that SQL very easily and copy and paste it out of the CDNs file directly into Postgres. Like these all, once you replace the named variable bit there, you can just issue that query. Again, it's really small, isn't it? But yeah, so it is clear SQL, luckily, which is nice. But yeah, anything else?